A student performs an experiment on two isolated conducting spheres, A and B. Sphere A is positively charged and sphere B is electrically neutral. The steps of the experiment are the following. The two spheres are brought into contact with one another for several seconds and then separated. Sphere B is brought into contact with the ground for several seconds and then the ground is removed. The two spheres are brought into contact with one another for several seconds and then separated. What are the charges on the spheres following this experiment? Take a moment to go ahead and look over that and see if you can find the answer. Okay, so what should be your answer here is going to be A, that both are going to be positively charged. Let's look at why that is. All right, so let me just I need to draw this on the board so that you can kind of see my reasoning here. All right, so we have sphere A and B, and it says that sphere A is already positively charged, and it says that sphere B is neutral. All right, so let's talk about why that would happen. So to begin with, sphere A already has a positive charge, so we don't need to really explain how it's going to get to a positive because it already has that. Let's look at how sphere B becomes positive. All right, so the first thing to note is that if you bring them into contact with each other, what's going to happen? Well, the positive charges that are here are going to attract the negative charges and repel the positive charges on the neutral sphere. So when it says electrically neutral, that does not mean that it doesn't have any charges. That just means that the positives and the negatives are equivalent and they balance each other out. So when you look at step 2, it says it's brought, so sphere B is brought into contact with the ground for several seconds and then the ground is removed. All right? So when you talk about what's going to happen with the ground, what the ground does is the ground is going to absorb any negative charges. So when you bring this down to the ground, what's going to happen is those negative charges are going to go into the ground. Then, when you bring them into contact with each other again, you're going to basically allow any remaining charges that are present on the one that has more magnitude. Again, this is going to have a higher charge because it already stands out as being positive. That's going to be transferring back to the second sphere. So both are going to have that positive charge. So again, just to kind of reiterate what I'm saying here, okay? First of all, sphere A has a positive charge. And when you bring them into contact, you're going to allow them to share that charge, to dissipate. So let's say that this has a neutral charge and this has a positive 4. When you bring them into contact, you're going to allow some of those charges to equalize, and so think about both of these as having a positive 2 when they come into contact. All right. In step 2, when you ground the charge for sphere B, the charge is released, it's neutralized, and then during step 3, the remaining charge on sphere A is again going to be shared between the two. All right? So that's going to result in both of these having that positive charge. All right, so looking at this image right here, it says the following simple circuit consists of a battery and one resistor connected by ideal wires. What a resistor is going to do is it's going to give you some ohms of resistance. It's going to reduce your current. It says if the value of the resistor is replaced with another resistor, that has a resistance of 4 times the initial value, how does the flow of electrons through the wire change? So for this one, you just want to give some arbitrary numbers to the formula and think about Ohm's law. And it's V equals IR. So let's say our voltage, let's just kind of make it up here. We're going to just invent some numbers. Let's say we have 100 volts. Actually, let's think of a multiple of 4. Let's say we have 80 volts. Let's say our resistance is 2 ohms. And let's say we have 40 amps. Alright, so 2 times 40 is going to be 80. Alright, if we change that resistor to one that has 4 times, so let's say we change this to 4 times 2, which is going to be 8 ohms. Alright, how does the flow change? So my voltage is not going to change. My source of power is whatever it's going to be. If this is an 80 volt battery or an 80 volt source of power, that's not going to be altered by how much resistance I have. What is going to be altered is the current, right? So here, 2 times 40 is 80. What times 8 is going to be 80? Well, that is going to be 10. So if my resistor is going to be multiplied by 4, it makes sense that my current has to be divided by 4. So it's going to be reduced by a factor of 4. And what that means is, translated, that means divided by 4. If something is reduced by a factor of 4, it's divided by 4. If it's increased by a factor of 2, it's multiplied by 2. So for this question, you should choose A. So similar questions should also be done the same exact way. It's just an application of Ohm's law. Alright. A permanent magnet is passed through a loop of wire. When is the electric potential difference in the loop the greatest? Alright, so that's like going back to this, where you have the magnet going through the loop of wire. So coming forward to this question right here. Again, this is, I think, our last question, but let's look at it. So when is the potential difference in the loop the greatest? And that's going to be, so what is the potential difference? So when we say potential difference, remember that in electricity is going to be your voltage. And this is potential difference of charges. So when you plug something into the wall, you have a lot of charges in that wall and that outlet, but not any out here. So you're going to have a lot more volts than if you just have like a standard 1.5 volt battery, right? So you don't have as much in here as you would inside the wall outlet. So when is the voltage going to be the greatest? It says when the permanent magnet is far away from the loop of wire. Well, that doesn't make very much sense. B, when the permanent magnet is passed slowly through the loop of wire. C, when the permanent magnet is passed quickly through the loop of wire. And D, when the permanent magnet is held still in the middle of the loop of wire. So D and B and A do not make any sense, because it's really that motion of the magnet going through, that back and forth motion that is very quickly, that allows us to generate that electricity. So it's the movement, it's that rapid back and forth movement of that magnet that generates the electricity and allows us to have that generation occur. So our voltage is highest when C, the magnet is passed quickly through the loop, when that is true. So real quick, just to finish up, tomorrow in class we're going to have a discussion, bring some questions to ask me, some things for me to talk about. Look over that EOC study guide. It is on eClass. You have access to it. It's produced by the state. It's free to download, free to use, publicly available. Please bring any questions or concerns you have so that I can address those. and go over those. Anything that you're confused about, I would like to address. I would like to set you up for success and help you to get the highest grade possible. Thank you for paying attention. Thank you for watching. I do appreciate it. And again, bring any questions you might have to me. Thank you.